In this two-part series, we're going to talk about this general mathematical concept that we're going to have to know to kind of be prepared for the MCAT. And the first thing we're going to talk about are these definitions of basic cosine, sine, and tangent functions, as well as their inverses. Now, for a lot of people, this might be really daunting, but I'm going to show you a really cool trick that makes it super, super easy to remember. And all we have to do is remember this trick, and we'll be so good for the exam. First, I'm just going to show you the pattern, and I'm going to explain it back to you afterwards, okay? So whenever we put something on this graph, or whenever we put something in this chart, we're going to divide it by 2 and take the square root of the number on top of the fraction. So when we have sine of 0 degrees, right, so these are degrees, by the way, just so we know, these are degrees. When we have sine of 0 degrees, it's going to be equal to 0 divided by 2, and we're going to take the square root of 0. Now you might say, hey, that's kind of redundant because the square root of 0 is 0, and 0 divided by 2, that's 0. But it's just a pattern that I want to show you guys. Now for the next one, so at 30 degrees, it's going to be 1 divided by 2, right? We're going to take the square root of 1 divided by 2. The square root of 1 is just 1, so it's just 1 over 2, but the pattern, for the sake of the pattern. At 45 degrees, we're going to do the same thing. Now we're at 2, so we went from 0, so here is 0, then we went to 1, now we're at 2. 2 divided by 2, and we take the square root of the top number. That's for sine of 45. Sine of 60 degrees, we're moving up another one, so 3 divided by 2 and take the square root of that number. At 90 degrees, we're going to do the exact same thing, so we're at 4 divided by 2, take the square root. Square root of 4 is equal to 2, and we divide by 2, so we're left with 1, and we'll do 180 at the end. 180 is just a little special. And for cosine, so that actually completes sine. That's all we have to know. And it's really just that pattern. It's really that easy. Now for cosine, it's really easy to remember because it's just the opposite. So here we started at 0, so cosine of 0 is 0. But now with cosine, we're going to do the same thing, but in descending order. So we're going to start with 4 divided by 2, the square root of 4 divided by 2, which is, as we already proved, was 1. So at 0 degrees, cosine is equal to 1, and sine is equal to 0. And same thing, moving down 1, now we're at root 3 over 2. When cosine of 30 degrees is root 3 over 2. Cosine of 45 degrees is going to be root 2 over 2. Cosine of 60 degrees, it's going to be 1, so root 1 over 2, but that's just going to be 1 over 2. Now cosine of 90 degrees is going to be root of 0 over 2, which is just 0. And that's it. That's really it. That's all we have to know. And that is the pattern. And the MCAT actually only needs you to know for sine and cosine. It only needs you to know 0, 60, and 90. But I just showed you the pattern for 0, 30, 45, 60, 90, and I'm going to show you 180 in a second. So really, it's not something to be daunted by. And 180, this is just something you're going to have to memorize. So for sine, 180 is 0. So notice it's the exact same, so I'm going to choose a new highlighter color. It's the exact same as what we saw over here. So sine of 0 is 0, and sine of 180 is 0. Now cosine does the same thing, except it flips the sign. So what we do here is we take 1, so we know sine of 0 is 1, and we just make it negative. So if cosine of 0 is 1, then cosine of 180 is negative 1. All right, now let's not get stressed out because now we're left with tangent. And a lot of people are get kind of scared of the tangent graph because it looks kind of strange. It looks a little weird. But I'm going to show you it's nothing to be afraid of because tangent is simply sine. So we use this symbol. It's called theta. It's kind of like, it's just a variable, and any angle can go in its place. So we just take, if we have the tangent at a certain angle, we call it tangent of angle theta. That's just going to be equal to sine theta divided by cosine of theta. So it's really nothing to be worried about. Now, let's see what this looks like. So, for example, tan of theta 0. So tan of 0, we're going to be left with sine. So sine of 0 is equal to root 0 over 2, a little redundant, and it's also, and then we have cosine of 0 is equal to root 4 over 2. Now remember that when we would kind of write this as, so we have root 0 over 2 divided by root 4 over 2. That's going to be the exact same thing as writing, it's going to be the exact same thing as writing root 0 over 2 multiplied by 2 over root 4. So we're going to take the reciprocal here. And all we do cross out those 2's, and we're left with root 0 over root 4, which would leave us with 0 over 2, which is always just 0. And we can do the exact same thing here. So at tan of 30 degrees, sine is equal to, so sine of 30 is going to equal 1 over 2, and then cosine of 30 is going to equal root 3 over 2. So we just take 1 over 2, divide it by root 3 over 2, which is the same thing as multiplying it by the reciprocal. So that, cross out these 2's, and we're left with 1 divided by root 3. Okay, now I could keep going, but it's really just the same math. So I don't want to spend the rest of the video kind of going through the rest of the tan functions, so I'm just going to kind of write them down. So this next one is going to be root 2 over root 2, which is just equal to 1. And we can keep following this math. This is going to be root 3 over root 1. That looks like a 7 over root 1, which is just going to be root 3. And then this one's a little different. So at 90 degrees, it's a little special because here, sine of 90 is 1, but cosine of 90 is 0. So what we get is this 1 divided by 0, and we know that we can't have that. That's undefined, right? So tan of 90 actually doesn't exist. It's not a real number, so it's an asymptote. We have a vertical asymptote here. So you can just say not a real number. And at 180, remember tangent is equal sine over cos, so we have sine of 180 is 0, divided by -1, that's just 0. Okay, so let's see what this could look like on a question. So let's imagine we have a vector. So we have a vector, let's change up the color. I want to do vector maybe in this purple color. Oh yeah, that's nice. So let's say we have this vector, and we call it vector, like just vector v, I guess. Now, a vector can be split up into 2 components. It can be split up into its vertical component here, so it's vertical vector. We can call this y. And its x component, we can call this its x component, or its horizontal component, we can call this x. Now, let's say we want to ask, okay, what direction is this vector going in? What direction? So we're looking for this angle theta. What is the direction of this vector? Okay, well, to answer this question, we're going to have to be given a few more, quite a bit more information. Let's say we're given the value of y. Let's say the value of y is root 3. So the magnitude of y is 3. Maybe it's 3 meters. And the magnitude of vector v is, I don't know, let's say 2 meters. And now we're left with figuring out, okay, what is this angle theta? Now, some of you might remember this saying here, so that's not it. You guys might remember this saying. It's called SOHCAHTOA. We covered it in high school, so SOHCAHTOA. And this is kind of like a mnemonic to remember how to find the side lengths or how to find angles in a right triangle. So this is a right angle triangle, by the way, because we have a little right angle right down there. Now, we have to know what sides we're given. So if this is angle theta, this side here, the side that opens up from angle theta, this is going to be the opposite. We call this our opposite because it's opposite the angle. And vector v here, this is going to be our hypotenuse. This is our hypotenuse. So we have to use whichever one of these relationships talk about the opposite and the hypotenuse. Well, so this stands for sine. So sine of angle theta is equal to the opposite divided by the hypotenuse. So we're going to use the so part of this relationship. So we're going to use so. Awesome. And that's going to be written as sine of angle theta is equal to the opposite divided by the hypotenuse. So let's write this out. We can now kind of fill in what we know. So do we know angle theta? No, that's actually what we're trying to solve for. We're trying to solve for angle theta. But we do know the opposite. This is going to be our y vector, and it's going to be divided by vector v, which is just equal to root 3 over 2. So we can kind of simplify this to sine of theta is equal to root 3 over 2. Okay, now this might actually look familiar because this is one of the numbers here. So look, root 3 over 2 is this number right here. Root 3 over 2 is that number right there. So let's talk about this. How do we rearrange this to solve for theta? Because remember, the whole point is solving for this theta. And what we can do is use this inverse function, what we call an inverse function. So what we do is we take sine, right? So sine inverse, so inverse of sine times, we're going to multiply it by this, or it's not multiplied, it's inverse sine of this ratio of side lengths. So it's going to be root 3 over 2 is going to be equal to angle theta. And this is what the inverse function means. So when we have an inverse function, that's what it means. It means we are isolating for the angle. So if a question ever asks you for something like what direction is this vector heading in, what angle is this what angle is this vector moving at, that means we're going to be using some kind of inverse function. Okay, now this is where this becomes really important. So it asks for a sine of root 3, or inverse sine of root 3 over 2. All we have to do, come up to our table that we made and find root 3 over 2, which is right here, and we just have to see what angle it is. So when we're looking at sine, here is root 3 over 2, and that's going to be 60 degrees. So when theta is equal to 60 degrees, let's write this down here. When we can do our therefore statement, therefore, when theta is equal to 60 degrees, sine of 60 degrees is equal to root 3 over 2. Therefore, we can say therefore, vector v is heading in a 60 degrees direction, or whatever. That's kind of the answer though. So that's how we'd approach a problem like this.